Hey everyone, Steven here with LuckyCasts, and I am really excited today to be talking about one of my favorite Crystal community shards, the Ameba static code analysis tool. Let's get it installed first, and then we'll talk a little bit more about why you'd want to use Ameba, what it's good for, some of the specifics around configuration, and how you can get up and running with it in your project. So we can get started by adding the Crystal shard to our development dependencies section here. You can see that it's at the Crystal Ameba/Ameba repository on GitHub, and I'm actually using the master branch in this case so that I can get all the latest and greatest code and help give feedback early on features that are rolling out, that kind of thing. However, if you want a stable version, then you can add the version parameter here with a standard semver string. We're going to go back to branch master though for this demo, and I'm going to run shards install. So I already have it in my file tree here, but you can see that there's a bin Ameba file over on the left side of the screen. And now I can run that with bin Ameba, and we're up and running. Next, let's figure out what some of these messages really mean, what the different categories are, and why we'd use Ameba in the first place. Let's open our first sample file about the linter category, and that'll help facilitate some of the discussion. One question you may be wondering about is why does something like Ameba need to exist at all? Crystal already has a built-in formatter, so what is the point? Why would I not just stick with that? The way that I think about it is that the Crystal formatter really controls the shape of my code and some of the more common and easy to agree to standards. So, for example, if I remove this trailing comma from my multi-line array, Crystal format will add it back. In my VS Code editor, whenever I save a file, I run Crystal format and apply the changes. If I pull these up onto one line, and I have these trailing and leading spaces in the array as well as the trailing comma, and I save, Crystal format is going to remove them for me. However, what it can't do is tell me, for example, that this website URL variable here is not used anywhere in this file. This is the kind of stuff that the Ameba linter really excels at. I could probably make this video an entire hour of just going through the Ameba rules that they've built up into this tool. However, I don't think that would be super productive, so I'm going to hit some of the high-level notes for each one of their categories, namely the linters, metrics, performance, and style, and then we'll get to some of the more nuanced approaches around how we configure the tool and how you could add it to an existing project that isn't completely adherent to the Ameba standards. Let's go through a few more of these linter category errors that I found would be good for a sample or things that I encounter often. One is the duplicate require message, which is great to make sure you're not duplicating any requirement statements. Another unused variable here for this large hash. We have a shadowed outer variable here for a block, which I find happens quite a lot in code when you're stubbing it out or doing a code spike. It's very easy to forget which variable names you've used. Again, the Crystal formatter or the Crystal compiler are not going to complain about what's here. However, it's not really doing what you think it's doing. We could fix this by first removing this unused outer variable. And because there's no longer an outer variable, the inner shadowing is not an issue. Down in this next method definition, you can see that I've got a topic block variable that's not being used. Again, I don't have to just remove it because Ameba's flagging it. I can place an underscore in front of it, and now Ameba won't complain, and users still know what that block content is. Another one here, maybe I did some refactoring, and now I have a literal in my string interpolation. Crystal format or the compiler won't care, but Ameba lets you know that this is unnecessary. You can just do a 1. Another thing that Ameba helps with is our application metrics, like cyclomatic complexity. Here I have a really poorly written method definition with lots of different branching logic that you can take. It makes the code really difficult to reason about, and it's going to make debugging this thing a nightmare. Ameba can flag that for me by noting the cyclomatic complexity, in this case I'm at 13, and letting me know that it's above my permitted value, which by default is 10, but you could make more or less aggressive based on your existing code base. Ameba can also help us with some performance-based warnings. Here I have an array of strings, and basically I'm calling two things that I could be calling one thing for in each of these examples. Here I'm chaining select and any when I could just be passing a block to any. In the second example, I'm chaining select into size when I could be using count and passing a block. Finally, I'm chaining map into flatten when I could be using flat map. In my mind, even if the performance here is negligible between the two methods, I still want to keep this rule in my codebase so that I don't have two ways to do the same thing. The last category we'll look at is style. Here I have a pretty nasty method definition, with lots of different errors. One thing I can do is remove is here. We'd prefer just to ask language array empty rather than is language array empty. Next, I have a redundant begin block. Because it wraps the whole method body, I can just remove that and let Crystal format pull my code back to the right level. Here I have a double negative, unless not. In this case, Ameba is going to recommend that I run it through if without the not. I'm also using while true, rather than the built-in Crystal method loop do. Lastly, I'm using an explicit return when I could be using an implicit return. The next thing I want to cover is how to configure Ameba. Maybe you're adding this to an existing project that doesn't follow any of the Ameba rules, or you just have one or two rules that you want to turn on or off in a specific project. We can do that through the .ameba.yml file. I have a really simple one here to show an example of enabling or disabling a rule globally and disabling a rule for a single file. However, let's say that in a real project, my Ameba output really does look like this. I have 12 failures, and maybe I don't want to resolve them all right now. I just want to get Ameba into my project and tackle them one by one. I can do that by running Ameba again and passing it the gen config flag. This is going to run the same checks, but it's also going to output to my ameba.yml file a set of rules that'll actually leave Ameba completely green. If we go back to our command line and we run Ameba again with this new YAML file it generated, we'll see 0 failures. Now I can come back to my Ameba YAML file and I can one by one remove these items, go back to my command line, run it again, and now we can see I've only got one failure to fix. This is a really easy way to slowly roll out this tool to an existing project and make the onboarding a little bit easier. I really hope you've enjoyed this walkthrough of the Ameba shard today, and that you'll consider adding it to your Crystal projects. Again, you can find more information and a link to the latest API documentation on GitHub at crystal-ameba/ameba. Until next time, this has been Steven with LuckyCasts. Have a great day.